Today we're solving problem 24 from the AMC 10A of 2021, and this is all fall. I should write that. Fall. Okay, each of the 12 edges of a cube is labeled 0 or 1. Two labelings are considered different even if one can be obtained from the other by a sequence of one or more rotations and or reflections. For how many such labelings is the sum of the labels on the edges of each of the 6 faces of the cube equal to 2? Basically, let's just take, there's 2 cases here, but let's just use the first cube. So we have 6 faces in a cube, right? 6 faces in a cube. This is about the intersection point. We have 6 faces in a cube. It's saying that each line can be represented as 0 or 1, and the sum of the lines of one face has to be 2. That means there's only one way to do this. 0 plus 0 plus 1 plus 1 is 2. And this has to be true for every single face. Okay. Well, the first case is where these 2 ones are like next to each other, and these 2 are 0. Okay. Well, now, we already reached our first point. Well, if this is 1, then these can be 0 or 1. But notice, these can be switched around. That's pretty interesting. If it's like this, these 2 have to be 0. Then this has to be 1. Okay. So it's like, kind of like Sudoku, I guess. Where if we can just like get one side done, we can start like kind of filling in all the other blanks. Okay. So what other face can we do? We have 0, 0. Well, this also has to be 0. And now, let's consider this big face. Well, we have 1, 1 here. This is 0, this is 0. This has to be 1. Well, now there's a few contradictions here. Not contradictions, but just like different ways we can do this. First of all, let's take this. These can swap. This is either 1 or 0. So that's, well, this is like 1 transformation times 2. Okay, that's the first times 2. Well, we see that this is still, well, yeah, this still works. 1 times 2. Now you might think that might be done, but actually, I think those can be swapped. Well, they can also be swapped in a different number of ways. These 2 are 0s. We can swap the 0s to get 2 more, and then swap these placements to get 2 more. Well, now this is just that 1 cube. We want to multiply it again. This is 16. Notice we multiplied by 1 more 2 in the end because this is the probability where it's like slanting this way, I guess. Slanting this way. Here's how I think about it. If the 1s are slanting this way, then it's going like this. But then now there's a second possibility where the 1s are diagonal like this. That's how I think of it. This is 16. Now the second case is where the first face, both 1s are on the top and bottom. But this can't be true for all the faces. It can't be true for all the faces because if they're all just 1 and 0 on all the faces, when we try that, we get 4 on the bottom and 0 in the... Yeah, it doesn't make sense. But we can still do some permutation. Not permutations, but changes. This is 0 or 1. 0 or 1. These 2 can be swapped around. That's pretty cool. Well, we found this. This is 1, 1. That means these 2 have to be 0. If Let's see. So these two have to be 0. That means this is 1 and this is 1. So this is also 1. Yeah, these are all the vertices, but this is like 1 combination times 2 since it's here, and then the zeros can be swapped, so the cube can be turned, so you have to multiply by 2 again. This gives 4. 16 plus 4 equals 20, which is our answer, and we are done.